Hello and welcome back. This is the first video on Section 6 in the prerequisites chapter, and this will be on rational expressions. And rational expressions are essentially the next step up from polynomials. So a polynomial, remember, is going to have terms, none of which will have any exponents that are negative powers or fractional powers. All the powers are whole numbers. A rational expression, we're going to take two polynomials and divide them. So for instance, this first example, it's clear that x minus 2, this will be a polynomial, x plus 2, this is another polynomial, and we can divide these. So this is an example of a rational expression. 4 divided by x, 4 is quite a simple polynomial, x is quite a simple polynomial. This next one doesn't look like a fraction, but any number divided by 1, we can make it look like a fraction, and then at that point this does look like a quotient, and again 1 is a polynomial, and so is 3x squared plus 1, and then likewise here at the end we've got another rational expression. The domain of an expression is going to be the numbers for which the expression is defined. So when is an expression not defined? Well, for instance, here in the second one, this is not defined when we're dividing by 0. We can't divide a number by 0, so this is not defined for 0. For x is equal to 0. The first one, on the other hand, x is just always defined. It doesn't matter what x is, it can just be anything that we want it to be. When we look at a square root, which is not a rational expression, remember that this is x to the 1/2 power, which this is not going to be a polynomial, and therefore it can't be a rational expression, but we can still think about the domain. Here, I can plug in any positive number that I want, and I can plug in 0. But I can't plug in negative numbers. So this is not defined for negative numbers, meaning x is less than 0. And then this last one, we've got a little bit of work to do. This is 3x divided by x squared minus 1. So again, the only way that this isn't defined is when we're dividing by 0. So we can't divide by 0. So the question is, when is this bottom fraction 0? Or when is the denominator 0? So we've got to do a little bit of scratch work off to the side. I need to know when this is equal to 0. The easiest way to do this will be to factor this. And this is a difference of two squares. We've got x squared minus 1 squared. So this is going to be x minus 1 and x plus 1. And the only way that something can be equal to 0 after we factored it is if one of the factors is 0. So we'll notice that this first factor is 0 when x is 1. So this is not defined when x is equal to 1. The second factor is going to be equal to 0 when x is negative 1. Negative 1 plus 1 is 0, or negative 1. So when we look at the bottom of the fraction, we can see that it's 0 either when x is 1 or negative 1, which means that we can't allow x to be 1 or negative 1, otherwise this fraction isn't defined. So this is just the domain, and this is a good thing to keep in the back of your mind as we're simplifying rational expressions here. So for the moment, let's focus on how we simplify. The first thing that we always want to do is we want to factor. Once we factor, we can start canceling things out from the top and the bottom. And factoring first means that it'll be easier to cancel. So we'll take a look at this, and we'll see what we can factor. The top, we already have x and 8, and this is factored pretty well. The 8 I could split into 2 times 2 times 2, but for the moment I'm just going to leave it as 8. The bottom of the fraction, I see that we've got a 2 as a factor of the first one and a 2 as a factor of the second one, so I can certainly pull out a 2. I can't pull an x out of the 6. There's no x in there. So for the moment, I'll see 2 times x squared plus 6. And we've got sort of this binomial expression, x squared plus 6. I can't factor this anymore, so I'm done with step 1. Next, I need to cancel common factors off the top and the bottom. And this 8, remember, I can split this into 2 times 4. So I can cancel a 2 out of the top and the bottom. When I cancel a 2, I'm left with a 4. And when I cancel a 2 on the bottom, I'm left with the x squared plus 6. So there's not a whole lot going on. We just need to factor things and then cancel. The factoring can be a little bit tricky at times, though. So let's do this next one. Here I have a difference of squares. I've got an x squared minus 1 squared. So when I factor this, I can factor this into x plus 1 times x minus 1. Again, when we multiply conjugates like this, we get a difference of squares. The bottom, I've got x squared plus 2x plus 1, and I notice that this is x squared, this is 1 squared, and this is 2 times x times 1. So the bottom is in fact going to be x plus 1 quantity squared. This is one of the forms that we've seen say in the previous videos. And now the top and the bottom are completely completely factored. And I can cancel the x plus 1 and 1 copy of the x plus 1. Remember that there's 2 of them because it's squared. So after I cancel that one, I'm left with an x minus 1 on top. And after I cancel out one of those factors, I'm left with an x plus 1 on bottom. So far so good. We can just factor and then cancel. Multiplying rational expressions, again, this is just like multiplying fractions. We multiply the tops and the bottoms, the numerators and the denominators. But it will be useful to factor things first. And after we factor, then we can cancel some things. And then lastly, we'll put our fractions together. This will make it just a little bit easier for us. So we've got 2 fractions here. We'll look at the first fraction first. The top, x plus 3, again, I can't factor this anymore, so we'll stop there. The bottom of the fraction, we've got an x squared minus 2 squared. So again, this is a difference of squares, so I can pull this apart into x plus 2 and x minus 2. So that's the first fraction done. And then we'll multiply this by the second one. I'll start with the bottom here. And what you'll notice is I've got an x squared and a 3 squared. So what this looks like is going to be x plus 3 quantity squared. Because in the middle, I've got x times 3, and I've got 2 of them. So this is 6x. The top of the fraction is going to be a polynomial that I'll have to work a little bit harder to. So maybe I'll do this scratch work off to the side. So we've got x squared minus x minus 6, and I want to factor this into 2 pieces. What you notice is that I've got an x squared out front, so I'm just going to put an x as both of my factors to begin with, and then I have a minus 6. So I want to put 2 numbers in here that multiply together to get minus 6, but when I add them together, I should get minus 1. And the trick will be minus 3 and plus 2. Why? Because if I take the last 2 terms and I multiply them together, minus 3 and plus 2, I get minus 6. But if I do the outer terms and the inner terms, I'll get x times 2 is 2x, negative 3 times x will be negative 3x. When I add them together, I do get that negative 1x in the middle. So let's write this down. X minus 3, x plus 2. Here, now I can start canceling things off the top and the bottom. You'll notice that I have an x plus 3 squared, and I have an x plus 3. So I can cancel, let me maybe do this in red. I can cancel 1 factor of that there and there. I also have an x plus 2 and an x plus 2. So what am I left with? On the top of the fraction, I only have an x minus 3 left over. And on the bottom, I can only get an x minus 2, and I still have one copy of this, x plus 3. So ultimately, when I'm multiplying my fractions, I'll factor first, which will make canceling a lot easier, and then at the end I'll just put everything together. Now, what's important is to remember what should be in the domain here. So notice that we canceled a factor of x plus 2 from the bottom, and now it's no longer on the bottom. We should remember that we can't divide by 0, so in particular, I don't want x to be equal to negative 2. If x was equal to negative 2 and I plug that in, I would be dividing by 0. Even though it doesn't show up in the final fraction, I have to remember that I canceled it earlier. Also, from looking at this, I know that x cannot be equal to 2, otherwise I would be dividing by 0, and also x cannot be equal to negative 3, otherwise I'd be dividing by 0 over there. Let's look at one more example, and in this one we're going to divide. Now, dividing fractions is the same thing as multiplying fractions. We just have to multiply by the reciprocal. So what does this mean? The first fraction stays exactly the same, and we're not going to change anything. The next fraction we're going to flip over and turn division into multiplication. So this becomes 3x squared plus 3 divided by x squared plus x minus 2. And now I will need to factor. So on top here, I've got x squared minus 2x plus 1. This looks like an x squared. This looks like a 1 squared. And what we'll notice is that this is going to be x minus 1 quantity squared. Again, this is one of the forms of fractions that we can work with. On the bottom here, I've got an x cubed and an x, so I can pull an x out of this whole thing, and then I'll have x squared plus 1. And here, I've got x squared and I've got 1 squared, but I'm adding them. And because I'm adding these, I can't factor this anymore. Moving on to the next fraction, I've got 3 times x squared plus 3. I can pull a 3 out of the top, and again I'll have that x squared plus 1, which is nice because I have an x squared plus 1 on both sides of the fraction. I'll be able to cancel those. And then lastly, I've got an x squared plus x minus 2. Again, this is something that I'll just do off to the side. I want to factor this, so it should be x plus something or minus something times another x plus or minus something, and I have to figure out what should go here. I know that it's just x and x because they have to multiply to give 1x squared. When I multiply these two guys, I should get negative 2, but when I add them together, I should get plus 1. So we'll take x plus 2 minus 1. Why? Because if I multiply the last two terms, I'll get negative 2. But if I add negative x and 2x, I get 1x. So this will be x plus 2 times x minus 1. And now I can start canceling. Like I already mentioned, I have an x squared plus 1 on the top and an x squared plus 1, on the bottom and then on the top. Likewise, I have an x minus 1 here, and I've got 2 copies of x minus 1 here. So I'll just cancel that, and I'll leave 1 copy behind. So what's on the top? I've got a factor of x minus 1 and a factor of 3. On the bottom, I have a factor of x and a factor of x plus 2. I like to leave this factored, but we could expand this if we want, just multiplying the 3 times the x minus 1 and the x times x plus 2. And we'll look at adding and subtracting rational expressions in the next video.